When an object is shot from the bottom of a long, smooth, inclined plane kept at an angle 60 degree with the horizontal, it can travel a distance x1, inclination decreased to 31. Same object shot with same velocity can travel x2, then x1 is to x2 will be. Now this is one such question where you of course, if you prepare the JEE advanced or the JEE level, you will definitely have shortcuts and other tricks to solve this in a very simple way, but I don't think any such thing would work here. So we'll have to find it out. So let's say if this is the plane, so object is shot from the bottom. Okay, so the object is shot from the bottom like this. After some time it will reach here and eventually it will reach the final position, right? Now we know that when an object is projected like this, the acceleration due to gravity g can be resolved into two components, which is g cos theta and g sin theta, right? So when the direction of motion is against the slope, against the gradient, g sin theta, the component of g sin theta acts as a retarding force. Now we've been asked to find out x1 and x2. See, when an object is projected like this, it goes in a straight line, right? It goes in a straight line. And when an object is traveling in a straight line, what do you write the equation as? You can write the displacement as s is equal to ut plus half at square. Now since velocity is same, we need another equation. So we have v square minus u square is equal to 2as. And what we can do here is, see, eventually what will happen is when the object is here, say this is projected, not projected, this is shot with the velocity, say v, say u, and when it comes to the final velocity, it is v. But this velocity is equal to 0 as the block will come to rest after some time, which means the final velocity component here is 0. So we have minus u square is equal to 2 into ss. The first, it is distance x1. So we have x1. So we have minus u square is equal to 2 into a. What is a here? A is the retarding force, which is g sin theta. And what we need to understand is, since it is retarding force, we need to use a symbol minus g sin theta. So what do we get u square as? U square is 2g into x1 into sin theta. Okay. So what is x1 from here? So x1 from here is u square by 2g into 1 by sin theta. Now since it is given in the question that it is shot at the same object is shot with the same velocity, the next displacement x2 can be written as u square by 2g because it is same velocity. But what will vary here? Instead of 1 by sin theta, so let's say it is, what was the first angle being projected? It was projected at 60 degrees, so we have sin 60 degree and the other would be sin 30 degree. And now when you divide these two, what do we get? So we get x1 by x2 is equal to sin 30 by, or to be more precise, this would be 1 by sin 60 the whole upon 1 by sin 30, which is equal to sin 30 by sin 60, which is 1 by 2 by root 3 by 2, which is 1 by 2 into 2 by root 3, is 1 by root 3. So the correct option here is option D. See, there are a couple of other things that you should be knowing really well while dealing with numericals which are related to the topic of motion in inclined plane, but let us not discuss this here. The reason why this question comes here is this is not related to projectile motion. This can actually be considered projectile motion in a plane. Yes, I do understand, but these specific topics are dealt in other chapters, which includes loss of motion and friction, right? Loss of motion and friction. So we'll discuss in detail these kind of cases when we reach that topic. So is there anything else in this question? Okay, no. So having said so, let's move on to the next question, which says,